Okay, so last time we saw universal instantiation, existential instantiation, universal and existential generalizations, which were the rules specific to predicate logic that let us introduce quantifiers or take the quantifiers away. Now we can combine those rules with rules of inference from propositional logic, modus ponens, resolution, and other ones that we spend a lot of time talking about in order to get rules of inference for predicate logic. Because sometimes it's just simpler to combine things and apply a rule than to do universal instantiation, then apply the rule, even though this is kind of what we are doing. So let's talk about the version of modus ponens. Remember, modus ponens was if P implies Q and P is true, then Q must be true. Let's make a version of it with quantifiers. And this one goes, again, way back to ancient Greece, to actually Aristotle, who had that famous syllogism, all men are mortal, Socrates is a man, therefore Socrates is mortal. So this is where we are using, as you could see, universal instantiation. All men becomes Socrates as a man. And this is where we use modus ponens. Socrates is a man, then Socrates is mortal. Socrates is man, therefore he's mortal. So one way of thinking about it, and this goes back to our examples with white squares, blue circles, and lemurs in the trees, is if you try for every predicate to think of all the places where it's true. So there are more mortal things than there are men. But in particular, if you look at the domain, the set of all mortal beings, it includes all the men. And in particular, if you look at all the men, Socrates would be there. So here is a structure. And again, you may recognize it from our circles and squares and lemurs. For every x, if x is a man, then x is mortal. Now we are doing instantiation. We say, let's take x to be Socrates. And now we could say, well, Socrates is a man. That's our second assumption. And from that, with that instantiation, from the first line that now became man Socrates implies mortal Socrates, we get that Socrates is mortal. So here is a structure of universal modus ponens. Again, if you think about it, we are skipping over steps. We are skipping over the step of instantiation. Man of Socrates implies mortal Socrates. But in the general form, it's there. So we write for every x, P implies x, P of x implies Q of x. And also P of A gives us Q of A. And again, think about Q as a bunch of things that are bigger than the set P of things, and A to be something inside of the set P of things. Okay, so let's look at a few more examples and not quite examples. Here is another argument. All cats like fish. Molly likes fish, therefore Molly is a cat. Do you think this argument is valid? Here is the structure. For all x, if x is a cat, then x likes fish. And we also know that Molly likes fish. But wait a moment, things here are going the wrong way. Before, the thing inside was whatever thing we talked about on the second line, the instantiated one. Socrates as a man talks about something on the inner circle of the diagram. but like in fish is the outer circle of the diagram, and it's entirely possible to be in the outer circle and not in the inner circle, but not the other way around. So let's try a few more examples. So again, here is the structure of universal modus ponens argument. And here is what Aristotle's version was. All integers are odd or even. 2 is an integer, therefore 2 is either odd or even. That's fine. So here, our implication would probably say for every number, if that number is integer, then it's either odd or even. And the next line will say, well, 2 is the integer, so it satisfies the left side of the implication. Therefore, it must satisfy the right side. So another example. All trees drop leaves. Pine does not drop leaves. Therefore, pine is not a tree. Is this a valid argument? You may be tempted to say, but wait a moment, what are you talking about? Pine is a tree, so something's wrong with your argument. Let's look at it closely. Is it something wrong with the argument or something wrong with premises? So if all trees drop leaves, if pine is a tree, it must drop leaves. But maybe, you know what? There are trees that don't drop leaves. So maybe the problem here is not that the argument is wrong, but that the premise, all trees drop leaves, doesn't really hold in the real world. So again, just like in a propositional setting, your conclusion can be weird even if your argument is fine if your premises are wrong. So far we just looked at everybody's favorite rule of inference, modus ponens. But you know what, just like we could make rule of inference out of other tautologies too, we could make the universal rules of inferences out of other tautologies. For example, if for every x, p of x implies q of x, and also for every x, q of x implies r of x, then for every x, p of x implies r of x. The reason we could do it is because, remember, with universal instantiation, as opposed to existential instantiation, we could give absolutely any names to our instantiated variable. And because it's universal quantifier, nothing stops us from calling the variable in the first line a and calling the variable in the second line also an a. If it were existential quantifier, we wouldn't be able to do it. So here is another example. This is essentially what we had before in propositional setting, but now it's written more properly. Rather than talking about some specific x, we talk about for any x, if x is greater than 3, then x is greater than 2. And it's greater than 2, then it's not equal to 1. And we can conclude, again, if x is greater than 3, then x is not equal to 1. As you could see, this is an argument that follows the structure that we just did, that transitivity rule. And again, my goal is not to make you memorize all sorts of different rules and syllogisms. What I'm trying to show you is how out of tautologies of the form something and premise and premise and premise and premise implies conclusion, whatever those premises really are, and rules of universal instantiation, generalization, and, well, they don't occur here, but generally they can, existential instantiation, generalization, you could actually build argument, whatever arguments you may need for specific situations. And in the next few lectures, we will look at some types of proofs that come out of different tautologies, different argument structures. Again, they're going to look like we are proving something about numbers, but really every time you read a proof, think, was it a universal instantiation just being used here? Aha, I see the word arbitrary. Maybe that's it. Was it an existential instantiation? If so, then the name for this variable must be something that haven't occurred before. Oh, great, we found a witness for something, then something exists that's a witness. So we'll play a lot more about it in the next few lectures.